Hello everyone. Today my project partner Tawake and I, Nischal, will be presenting on the topic Way in Motion Camera Capture System. Starting off with the presentation, this is the project overview. The next slide will start off with the aim and objectives, followed by the introduction of what is Way in Motion system. After that, the methodology and the flowchart of our system will be discussed. Then the results will be shown along with discussions of each part. The weight limit and computations will be mentioned and explained. The video capture system using Motion iOS system will be shown, followed by the 5-step process of the license plate recognition using Sobel edge detection. Moving on, we will just conclude our project with some important recommendations at the end. The aim of our project is to design a Way in Motion camera capture system and utilize image processing to extract the license plate of a vehicle. To achieve this, the following objectives are introduced. Firstly, to lay out the architecture of the Way in Motion system, gather information on how to capture the vehicle and send data. The second objective is to use Raspberry Pi and the Pi camera to capture the video and image and send to a computer directly. The next objective is to design a Way in Motion system and then conduct tests with the vehicles and models to display the working principles of the system.
Thank you, Nishcho, and hello everyone. The question in hand is, what is a Way in Motion system and why is it useful? Land and Transport have been dealing with overweight vehicles for road and traffic safety measures. The current system uses the scale or stationary weighing, which may be stressful for vehicle owners waiting in a long queue for their vehicles to be weighted. This is where Way in Motion comes in here. Way in Motion, or WIM for short, measures the weight by determining the wheels, axle group, front and rear bridges, cross, and the speed of the vehicle while in motion. This is achieved by implementing sensors on the road to weight vehicles in their daily routine, removing the stress from waiting in a queue. All the information then collected together with the license plate are then analyzed and saved in a checkpoint. Thus, if the vehicle found overweight, the information will then be sent to authorities for further actions. However, implementing such system is very expensive due to its complexity, with many factors affecting the accuracy of the results, like for example, the weather condition of the site. This is one of the reasons why the system is still in its infancy and cannot be mathematically modeled. Therefore, for our design, we have considered some limitation of our system. With the first, as we are to build a concept design of the actual system. The speed ranges are from 10 kilometers per hour to 30 kilometers per hour. Temperature and thickness of the road will not be considered. Weather condition will not be considered. And the quality of the camera is what we have available. Moving on to our methodology and flowchart of our WIM system concept design. Looking at our system flowchart, we will start by generating an electrical signal illustrating a vehicle passing over the weight sensor, then further analyze and compute the weight. The code then checks if the weight is over the maximum limit or not. If not, then no action will be taken further. However, if yes, the Raspberry Pi camera will start recording 10-second video of the vehicle, and from there will be extracted into our image processing for license plate recognition, and then save data to document and send to authorities.
Thank you, Tawake. Moving on, the weight was computed using the formula provided. The inputs for the equations set by the user are the vehicle speed and the load signal, which will be presented in the following slide. The following are the assumptions made based on an actual system. The width of the sensor is selected as 15 meters. The slow varying idle level BI is set to 0, considering no rough idle was caused from the vehicle. The calibration factor alpha was set to 50 based on the maximum weight limit. Therefore, for our system, we set the weight limit of 800 kilograms. To start off with the results, two different electrical signals were simulated. These signals indicate the axle load that was pressured on the system. For our system, we based the weight computation on a single axle to illustrate the working principle of what a sensor would produce, which is multiple based on the number of axles the vehicle has. Figure 1 shows the generated electrical signal, which was computed to provide a load of 11.03. This was done on MATLAB Simulink and later sent into MATLAB Workspace, where the formula mentioned earlier was coded. The input speed provided was 20 km per hour, and therefore, using the formula, the computed weight was 735.58 kg. Since the weight limit was set as 800, the vehicle was declared within the weight limit, and as discussed earlier in our flowchart, no action is taken towards this vehicle. In a similar way, the second signal was generated and the load was found as 12.87 with the same speed of 20 km per hour. The weight computed was found as 858.81 kilograms. This time around, it was seen the vehicle is over the weight limit. Hence, the next step of our system would take place. This will be continued from my project partner Tawake.
Recording the vehicles. In order to achieve this, we utilize the advantages of Raspberry Pi compatibility with software by using the Motion Eye OS to control our Raspberry Pi camera. With this software, we have programmed it to start recording overweight vehicles passing by in motion for 10 seconds and save, and then turn back off again automatically. A user from the office can then easily access and download the videos from the Raspberry Pi by connecting to the Raspberry Pi Motion Eye OS IP address. The videos are then processed using MATLAB from the office. Moving on to our license plate image processing, we created some GUI figures with MATLAB software for user-friendly interface in processing the images of videos. As illustrated by our flowchart, it begins with choosing the method for processing. If video is chosen, then a prompt window will pop up for the video to be loaded to. After the video is processed and all the frames extracted, the system will proceed to the license plate recognition and weight input. After license plate is extracted, the information will all be saved and generated into an Excel file. This slide shows how the video was processed and all the frames extracted and saved. The system will then select the optimal frame for the image processing.
Thank you, Tawake. Moving on, the next step is where the license plate recognition for the vehicle will be discussed. This is a 5-step process which will be discussed on the following slides. Starting off with the first step, which is image acquisition. One of the many frames that were extracted earlier were selected and inserted into our MATLAB program using graphical user interface. The Pi camera used earlier was able to capture a clear and good quality image as seen in figure 7. Also note that this is in RGB format, which will show relevance in the next slide. Moving on, the pre-processing is the second step, which involves the conversion of the image. The RGB image that was mentioned earlier was converted to grayscale and then converted to binary using pre-processing. In this process, all the unnecessary noise are also removed. The third step is known as the plate region extraction. This step involves edge detection, where the license plate is extracted using Sobel edge detection. This process removes all the non-wanted objects from the figure 7 and saves the extracted license plate region as a new image as shown in figure 9. The fourth step is known as character segmentation. Individual characters are segmented in order from the first letter K to the last number 0. Each of these characters are saved as a new image for the final stage to take place. The importance of this stage is that the character should not lose its original features while being segmented. For this case, figure 10 shows all the characters has been segmented correctly. The final step of license plate recognition is known as character recognition. In this stage, it shows that the individual character has been recognized in the same order it was segmented. The characters were individually tested with a template of characters that was included in the system using the optical character recognition, which is also known as OCR. With this, the final process of the license plate recognition and the next process of the system follows. This slide shows a video of a brief process of how the 5 steps are implemented. The image acquisition process starts by pressing the Detect Image button where the image is placed. Once the image is inserted, the other process will start straight away. As you can see, the pre-processing and region extraction takes seconds to process. Afterwards, notice that the individual characters are segmented and finally, the license plate is recognized.
Finally, the overweight vehicle database. This is a snippet of the information that was automatically saved by the system into an Excel document ready to send to authorities. As you can see, the weight was recorded to be 858.17 kilograms, which was over the assumed maximum limit of 800 kilograms. Therefore, the vehicle is classified as overweight. The license plate and pick of the vehicle was also successfully captured, and also the location, date, and time. In conclusion, the concept of the WIM camera capture system was successfully designed and discussed. The overweight vehicles were determined and implemented license plate recognition successfully. The information of the overweight vehicles was also successfully recorded and documented. These are some of the recommendations for future scope in order to successfully implement the actual system. Piezoelectric sensors are preferred for weight signals due to its more superior than other weight sensors. Inductive loops can also be used for sensing approaching vehicles and operating the system. A better 4K camera could be recommended for better resolution and identifying license plate and recording vehicles. Here is our references from research and where you can learn more about our system. That is all for my partner Nishcho and I, Tavake. And to end, we thank you so much for listening. Over.